In the environment, in power plant, factories, on the road and in the home, there are sensors that are designed to detect sudden events, to log these or to alert us. The aim of this video is to show how these detectors, which spend much of their time waiting for events, can be made less power hungry in order to reduce battery size and to extend battery life. A sensing device uses power to do two things: listen and react. Both require power. Some sensors use most of their energy to do the listening. One example of this is a temperature sensor on a bearing. It listens for years until the bearing finally overheats at the end of its life. Another example is traffic flow monitoring, where the traffic sensor listens by recording thousands of measurements every second. This frequent polling ensures that the sensor can't miss the brief event of a tyre rolling over the sensor. Once the tyre arrives, the sensor reacts by recording the car. In this example, almost all of the energy has been used for listening, during which no useful information was gained. This video shows how to eliminate this listening power for sensors that wait a long time for events or where events are very short. Keeping these devices alive and listening normally requires power to carefully time listening and sleep modes. We have developed a method of eliminating this keep alive power drain. This uses minute, insignificant quantities of energy from the event that the device is waiting for. This energy switches on battery-powered devices exactly when they need to react. This detector uses over 1,000 times less energy than existing detectors. 5 picojoules of energy, and only around half a volt, are enough to create a turn-on signal. This is so little that many sensors can provide this without requiring a power supply or any amplification. Now, with no power being used from the battery, the system is alive and listening. So we can stop using power for listening, sleeping, timing, receiving, etc., and save our battery for reacting to events. As this system is both triggered and kept alive by the sensor rather than the battery, we call it sensor-driven. This patent-pending voltage detector is a low-cost chip that is small enough to fit into many autonomous electronic devices. You can find data sheets for the chip and request evaluation samples on our website. There are a number of application areas for sensor-driven monitoring where elimination of the listening energy has significant advantages. Detectors and loggers, which can now be powered for decades from tiny thin film cells. Battery-driven sensors and monitoring systems where the long-term reliability and battery life are increased and size decreased. Remotely read active RFID sensors on machinery, as these can be made smaller with longer lifetimes. The sensitivity of the voltage detector also allows the elimination of mechanical switches and acoustic remote control without the need for receivers to be continuously powered up. Sensor-driven long-life detectors can monitor many parameters, including upper or lower temperature limits, strain, stress, pressure presence or intrusion, sound, cracks or ultrasonic signals, light, and leakage or ingress. So if you think your project or product should be sensor driven to extend the battery life or to reduce its size, then please get in touch.